So we have example here. Um, this is a different beam. This is a cantilever beam. What we're gonna do is we're gonna still solve for the reaction, but of course, let's follow the first step from left to right. Let's call this as A, and then with this distribution, it's a triangular distribution. It ends here, so this would be point B, and no load, but at the end, this is now the end, there is point C. Okay, so let's draw the free body diagram of the beam. So this is the beam, and then let's make a triangle. So here, no, here, somehow during the pita. And there. So let's make the line of the distribution, and this is 50 kilonewtons per meter, and with this you have also the 90, that load. So ato na siyang i-perfect. Hindi siya mo-perfect. Ano na lang. And this one is 180 kilonewtons per meter. And then let's make this as a picture. There. Because later on we're going to describe this one, the rotation. Because of this force, this moment, this will rotate in that manner. Or kanina lang. Let's just delete this. So kanina lang atong i-himaong picture. Oops. So let's make this as a picture, and this one let's transfer it here. So this picture here will rotate the 100 kilonewtons, so something like that. No. So this one, it's gonna rotate like that. So it's clockwise rotation anywhere. Bisag asa pa ang point of rotation. So it's still going to be clockwise. Okay, let us provide 6 meters here as the distances and 2 meters here. And then let us provide a letter here. This is point A, this is B, and this is point C. And of course, since we have a distributed load, we're gonna get its components, resultant rather. This is a triangular load, therefore the resultant is found 1/3 from the heel, this one. This is 1/3 of 6, that's 2 meters. And from the toes, this is 2/3 of 6, and this is 4 meters. So the resultant, by the way, is actually area of a triangle, the same roughly as area of a triangle, so that's 1/2 of 50 times 6. So this is 150. Is it 150? Let's get our calcu. So 0.5 is 1/2 times 50 times 6. Okay, that's 150. Okay, next, at point A there is a fixed support. So whenever there is a fixed support, it's gonna give you vertical reaction AV, horizontal reaction AH, and of course the rotational moment MA. So in cases like this, in cases or in case like this of a beam, actually the first thing that we're or this or yes, it's the first thing that we are gonna do is the same from the previous beam, but instead of doing the summation of moment immediately, we're gonna have the summation of forces after the summation of forces vertical after the summation of forces horizontal. Okay, so let's start. Summation of forces horizontal equal to 0, clockwise positive and counterclockwise negative. So along the horizontal, it's only AH, therefore immediately AH is 0. And then again, instead of having the summation of moment for this type of beam, since this is a cantilever beam, then we have to proceed with summation of forces vertical equal to 0. Okay, so we're done. Upward and downward as forces positive and downward negative. So what are the forces vertical? You have AV. AV is upward and downward 150. And that's equal to 0. There are only two forces on the vertical side. And then transpose 150 to the other side, it will become positive. So this is now our load, AV, or reaction AV. Okay, next. Let's do the summation of moment. And since there is only one support, then it's better to use the summation of moment rotation about the support. So it's point A. It's always. So mag-rotate all the time in getting a reaction all the time at the supports. Since usa naman ang support, then you choose point A. No choice. So clockwise positive, counterclockwise negative. Okay. So we already have 150 as the resultant, so it's gonna rotate clockwise because the force is downward. So it's gonna rotate about point A with a clockwise direction. So it's 150 positive times the distance. We already got the distance equal to 4 meters. And then this 180 rotate, it's gonna rotate clockwise because the direction is clockwise. We assume that the direction is clockwise. So that's 180. No, not assumption because that's a load rather. So that's 180. And no more moment arm. Why is this kilonewton per meter? It should be kilonewtons meter. No moment arm because it's already in moment unit, right? A moment, remember, is a force times distance, where moment is force, unit is Newton meter. So like that, the same ra na sila. So since moment naman ang ato ang given, then no need to write any moment arm. So clockwise. And then for MA, we assumed MA to be counterclockwise. So it's negative MA. That's our assumption. And then that's equal to 0. So you have MA, transposing it to the other side, and that's 150 times 4 plus 180. So MA is equal to, let's get our calculator, it's 150 times 4 plus 180. It's 780. And this is kilonewtons meter. That's our moment. So how do we know whether our answers are correct? Of course, we're gonna do the checking. How do we check? Since nahuman naman ta sa point A, you still have actually point B and C. The reason why previous examples we did not rotate at the points where no support, because we don't want our supports or our one of the supports influence our answer, or can sometimes magod we might not be able to get the answers correctly, so mo nang ma-influence ang imuhang answers with the wrong answer. So it's now going to complicate your solution. But actually, you can get the summation of moment anywhere as long as it's convenient to you. Okay, so I'm gonna choose point B as the checking. So let's do the checking, and we'll have summation of moment about point B as the point of rotation, clockwise positive, counterclockwise negative. So in that case, this 150 will rotate about point B with a counterclockwise direction. So it's negative 150. The moment arm is 2 meters. And then MA is counterclockwise, so that's negative MA. And then AV, it's gonna rotate about point B with a clockwise direction, so it's positive. Plus AV, and then moment arm is 6 meters because the distance of point A from point B is 6. And then the last one is 180. Positive because it's clockwise. And then you equate that to 0. Okay, you get your calculators, and do not forget, by the way, to substitute the values. So this is 780 as MA, and then AV as 150 times 6, then plus 180 equal to 0. So you have negative 150 times 2 minus 780, then plus 150 times 6, then plus 180. So our answer is 0. So we have proven that all our answers are correct. Okay, so let's proceed to the next example.